Alright, let's look at a method for solving an integral called a trigonometric substitution. Now, we use trig substitutions whenever we have an integral that has part of the integral in the form the square root of a squared minus u squared, or the square root of a squared plus u squared, or the square root of u squared minus a squared. So the first thing we have to do is identify that this is part of the integral, or the integrand, and this would be the main part of the integrand. Okay, and so of course the a is some constant, the u is some variable. Okay, and it's going to be one of these three cases. If we have the square root of a squared minus u squared, then we need to use a substitution where we let u equal a times the sine of theta. Alright? And then I'll go through what we have to do to actually solve that. But we need to let u equal a sine theta if we have the square root of a squared minus u squared. If we have the square root of a squared plus u squared, we need to use the trig substitution and let u equal a tangent theta. Alright, and if we have the square root of u squared minus a squared, we want to use the trig substitution and let u equal a secant theta. So the first thing that you have to do is recognize which one of these substitutions are we doing, or is the problem, what form is it in. So for example, let's say that I had the integral of 1 dx over x squared times the square root of 9 minus x squared. And so the first thing I have to do, again, is you have to recognize that this is part of the integrand, and that this right here is in the form the square root of a squared minus u squared. Now once you recognize that it's in that form, and even if you didn't recognize that at first and you just tried to start integrating, notice you can't. You can't let what's under here be your u and have your du on the outside. That doesn't work. You can't integrate each term separately. So it doesn't fit any of the rules that we have. And so then once you know it doesn't fit any of the basic rules, that's whenever we have to come to the realization that we have to use a trig substitution to integrate this. Okay? And so it's in the form u equals a sine theta. So the first thing that you need to write down once you figure out you're going to have to use trig substitution is, what is our u? If u squared is equal to x squared, then our u is just equal to a sine theta, or x, that's what we're squaring, x is equal to, what's our a? A squared is 9, so a is 3 sine theta. Alright, so x equals 3 sine theta. What will dx be equal to? The derivative of x is dx, right? That's going to be 3 cosine theta. So here's what we do now. So we need to, where we have an x that is not in the radical part, anywhere that you have an x, you need to plug in 3 sine of theta. Okay? And you can even do that in the radical part, and I'll show you. But the main thing that we need to concentrate on first is look for other places in the integrand that aren't in the radical part, and plug in 3 sine of theta in for those. Then where you have a dx, we took the derivative of 3 sine of theta and got 3 cosine of theta. And that is 3 cosine of theta d theta, because we took the derivative of the theta. Okay? So where you have a dx, you want to plug in 3 cosine d theta. So I'm going to rewrite this integral. Everywhere that I have an x, I'm going to put 3 cosine of theta. And where I have a dx, I'm going to put 3 sine theta everywhere I have an x. I'm going to put 3 cosine theta everywhere I have a dx, which is only one place. And look what it does. It changes my integral now into I have 3 cosine theta d theta. I plug that in for my dx. Where you have an x, you plug in a 3 sine theta. So that's going to be 3 sine theta squared, because that's x squared. And then it's going to be times the square root of 9 minus, now plug that in, again, 3 sine theta squared. Now, the stuff under this radical is going to simplify. And the reason that we've actually plugged this in is because we can simplify it in this way. Now, this stuff out here may or may not cancel or simplify with stuff. You just need to do the algebra and trig part there. Okay. So this will be the integral of 3 cosine theta d theta over, that's going to be a 9 in the bottom there because 3 times 3 is 9. Sine times sine is sine squared. Alright, and let's see what happens under the radical now. This is always going to happen under the radical, something like what I'm about to do under all the radicals, regardless of what type of trig substitution you're going into. Something like what I'm about to do is going to happen. So right here you have 9 minus, when you square that, that becomes 9 sine squared. In all 3 types of substitution, you're going to be able to factor a constant out, and in this case it's a 9, and the way you factor is you factor under the radical, so it'll be 9 times, what would that leave? 1 minus, then you factor a 9 out of that, that leaves sine squared. Now, this right here should look familiar. 1 minus sine squared theta. That is part of the Pythagorean identity. 1 minus sine squared theta is the same thing as cosine squared theta. So now, what do I have under the radical? I have the square root of 9 cosine squared. The square root of 9 cosine squared is 3 cosine. Something like that's going to happen with all of the trig substitutions. You're going to be able to simplify this radical in such a way that it becomes one term. Okay. So what would I have now? I have 3 cosine theta d theta over 9 sine squared theta. And then remember I said this becomes 3 cosine. That's because 3 cosine times 3 cosine is 9 cosine squared. When you take square root of that, it becomes 3 cosine. Alright. Now, on this problem, that cancels out with that. And so now, by using trig, I've actually simplified this integral, believe it or not. That's a 9 in the denominator. You bring out a 1/9. And then what is 1 over sine squared? If you bring that to the top, don't make it sine to the -2. It's not. It's cosecant, right? Cosecant squared. So by bringing sine squared to the top, it becomes the reciprocal function, so it's cosecant squared. Alright, and you can actually integrate cosecant squared, right? Because you can think of something that when you take the derivative of it, you get negative cosecant squared. Do you know what that is? It's cotangent. So I would just need to make that negative. Because the derivative of cotangent is negative cosecant squared, right? Right. So you may be thinking, well, now I'm done. Because I just got the answer. And it's plus c, of course. The only problem is, my original problem, look at my original integral here, it's in terms of algebra. And so we used a trig substitution to actually simplify this integral, believe it or not. When we got to the end, we got an answer in terms of trig. What we want to do now is change this trig back into algebra. The way that you do that, really the key to doing that, is this statement right here. You go back to where you have x equal to something, and it's a something times a trig function. Okay, write that down again. So x equals 3 times sine of theta. Now, I could divide both sides by 3, and I could have sine of theta is equal to x over 3. Now, if you remember your trig, x over 3, you can write this in a triangle. Let's call this angle measure right here theta. And remember, sine is equal to, in right triangle trigonometry, sine is equal to opposite over hypotenuse. Okay, so the top is opposite, Here's the opposite side. Hypotenuse is the slanted side, so that side is 3. This side down here, once you have it set up, this side down here, the way this works is going to be this square root of 9 minus x squared. However, if you want to go through with the Pythagorean theorem and solve for this side, you're going to get that radical part, 9 minus x squared. Go through and do it. You know, this side squared plus this side squared equals this side squared. So you can go through and solve for this if you need to. But it's going to be that radical part. All right. Now that I have this triangle drawn, you say, what does this triangle have to do with anything? Well, my answer over here is in terms of cotangent. So if I remember the right triangle trigonometry for cotangent, remember tangent is opposite over adjacent. So cotangent is adjacent over opposite. Going from this angle measure, the adjacent side is the square root of 9 minus x squared. The opposite side is x. So this is negative 1/9 times the adjacent side, square root of 9 minus x squared, over the opposite side, x plus c. So now we've changed this trig answer back into algebra using a right triangle. Okay? Let's look at another example. Alright, so let's look at the integral of x cubed over the square root of 16 minus x squared. So you see there's a radical part here in the denominator. Notice that it's not a u du problem, so it's not just a u substitution, and there's no rule that fits this integral. So we need to compare it to these three forms, which I chose one that would be the same. It'd be sine. So I have the square root of some constant squared minus some variable squared. All right, constant variable. So that substitution is a u equals a sine theta substitution. So in this problem, what is u equal to? U is equal to x. So I have x equals, that's going to be 4 sine theta. And dx is equal to 4 cosine theta d theta. So what do I need to do? Everywhere that I have a dx, I need to plug in 4 cosine theta d theta. That's only one place. And then where I have an x, I need to plug in 4 sine theta. I'll do that here and here. And remember, under the radical, something's going to factor out, and you're going to be able to plug in a trig identity. That's just the way that it always works. Okay? So this is going to be the integral of, now when I plug this in, this 4 sine theta, that's cubed. So be careful there. You need to make sure when you cube that, you say 4 times 4 times 4. And then sine times sine times sine. Alright, your dx is 4, and that's cubed, 4 cosine theta, d theta. So you have another 4 there. And then under your radical, you're going to have 16 minus 4 sine theta squared. You see, this is squared. So that's actually going to be 16 sine squared theta. So when you rewrite it, rewrite this and factor a 16 out under your radical. Okay? So let's see, we have 4 to the third times 4 to the first, that's 4 to the fourth. So 4 to the fourth is 256. So I'm going to write that on the outside of the integral. So it's 256 times sine cubed theta times cosine theta over the square root of, I'm going to factor that 16 out, that's 16 times 1 minus sine squared theta. Okay? And 1 minus sine squared theta is cosine squared theta. So when you take the square root of 16 cosine squared, that's going to be equal to what in the denominator? 4 cosine theta. Alright, and so this cosine and this cosine cancel out. I didn't write my 256 in the front. There's a 256 there. You can also bring this 4 out now. So if you bring that 4 out, then you're dividing 256 by 4. Alright, and you get 64. So this is equal to 64 times the integral of sine cubed theta d theta. Alright, so the way that you do this is by using your rules for integrating sine and cosine that we went over in the last section. So if this is odd, what did we do? If that's odd, then you can bring out a sine of theta, and if I do that, I'll be left with a sine squared. And so I want to now convert this over to 1 minus cosine squared. Now be careful here, because when you do that, you have a sine on the outside, and that sine is not the du for everything. You say, wait, we went over the rules, we factored out a sine, everything else we converted over, but then remember you multiplied a cosine back in. If you don't have a cosine there to multiply back in, this first integral is just going to be sine of theta. If I multiply that back in, that'd be sine of theta. So that's not the du for this. That is, however, the du for the second term. Because if you let u equal cosine, du is sine. Well, you can't do the u and du since that's a 1. So if all that confuses you, rewind it and listen to it again. If that still confuses you, multiplying that back in, remember, if you add or subtract terms when you're integrating, you need to integrate each term separately. So if I multiply that back into both terms, you know, this is two integrals, this integral and this integral. So for this integral, we know what the integral of sine is. For this integral, you let u equal cosine, so then your du equals negative sine. Okay, and it's present. So this is the integral of u squared. Just have to bring out a negative. Alright, so this is 64 times the integral of sine is negative cosine. And then if this is the integral of u squared, the integral of u squared is, and you got to bring out a negative, so it's going to be plus u cubed over 3 plus c. And what was our u? Our u was cosine, so you come back and put in your cosine. So I have negative 64 cosine theta. Then I'm going to have plus 64 divided by 3 cosine cubed theta plus c. Alright, so I plugged my u back in, and now I don't want to leave my answer like this because this isn't algebra. This isn't the way that it was originally set up. So the key to making this triangle, to convert this back over to algebra, is this right here, x equals 4 sine theta. So now I'm going to come in and make a right triangle. X equals 4 sine theta, so sine theta equals x over 4. And remember, in right triangle trigonometry, that's opposite over hypotenuse. So if I make this theta, the opposite side is here, is x, the hypotenuse is 4. This side down here is going to be that radical that we had, 16 minus x squared. But feel free to use the Pythagorean identity, or the Pythagorean theorem, with these two terms and find this side. And you'll see it is the square root of 16 minus x squared. So cosine and cosine, I just have cosine cubed here. So for cosine theta, the cosine of this angle measure is adjacent over hypotenuse. Okay? So it's going to be, this is the adjacent side, this is the hypotenuse. So my answer is negative 64. Adjacent is square root of 16 minus x squared over hypotenuse is 4. Plus, now look what I do when I plug it in right here. I have to cube it. So I have 64 over 3. But then you have to take this, 16 minus x squared over 4, and cube it, plus c. Alright, so let's see what that's going to give me. That's going to be negative 16 square roots of 16 minus x squared plus, now when you cube 4 down here, 4 times 4 times 4 is 64, so those are going to cancel out. For this top, I would just write this, if that's the square root to the third, so I would write that as 16 minus x squared to the 3/2, because it's a power to a power, so you just multiply. Remember, this cubed is going to cancel that out, but then you're still going to have a 3 right here. So that's going to be 1/3 plus c. The only other thing that you could do, it looks like, is factor out a 16 minus x squared to the 1/2 power. But I'm fine with you leaving your answer like that. But just know that you can factor out 16 minus x squared to the 1/2. And what that's going to do is that's going to leave you with, you'd have negative 16. And then you're going to have this thing to the first power if you pull 1/2 out. And so you're going to have plus 1/3 times this thing to the first. So you could write that as plus 16 over 3 minus 1/3 x squared. And so then you can come in here and simplify if you want to. You could even multiply through by 3, but you know, if you put a 1/3 somewhere. But I'm fine with you leaving your answer just like this up here. Sometimes factoring out will simplify, but in this case it does give you some fractions, which then you'd probably want to, I said multiply by 3, I'm thinking about maybe once you put these two together, factoring out a 1/3 out of all of them, that would probably be the most correct thing to do. I'll show you what I'm talking about. So that's 48/3. It's going to be negative 48/3. And so that gives me a negative 32/3 in here. Negative 32/3. And minus 1/3 x squared plus c. What would probably be done in a textbook, or you know, if you just always want to try to write the simplest or most correct answer, which is a good habit to get into. If you factor out a negative 1/3 here now, negative 1/3, then you can make that a positive 32, and you can make that a positive x squared. So then it will be x squared plus 32. All right, plus c. Let's look at another example. What if I took this same example here, right here, x cubed over that, and I changed it into, instead of x cubed, I'm going to make that an x squared. Let's see if that would change my answer any. Alright, so I have the integral of x squared over the square root of 16 minus x squared. Alright, notice again, it's not u and du, so you don't get out that lucky. It's not just u substitution. When you see the square root of a squared minus u squared, whether it's in the numerator or denominator, anywhere, then you want to use that u equals a sine of x substitution. So I have x equals 4 sine of x again, and my dx is the same. It's 4 cosine of x. Let's plug things in and see what happens. So if I plug in my 4 sine of x in the numerator, then that's going to be 4 sine of x times 4 sine of x. That's 16 sine squared x over, now what happens in the denominator? I'm going to have 16 minus, and when I plug that in, that's 16 again, right? 16 sine squared x. And don't forget your dx. I got to plug in 4 cosine for my dx. Alright, so under here I can say 16 times 1 minus sine squared x. Right, and you can say that's cosine squared x, so I'm taking the square root of 16 cosine squared. That's going to be 4 cosine. Alright, so I'm going to have the integral of 16 sine squared, and I know I'm using x's, but I'm supposed to be using theta, so those are all theta, 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 and that's d theta. So you might want to get in the habit of doing that. Once you make your substitution, change all these to theta. Theta. It really doesn't make a difference as to what we've just done, but that is all theta. If you saw theta and were wondering why you may have had x instead. Alright, and we said this was 4 cosine, but doesn't this 4 cosine and this 4 cosine, wouldn't that cancel out? Yes, it would. And so I'm left with this integral. And so, yes, it's going to be a little different, because remember what I was left with before? I was left with, over here, sine cubed, and we had to use our special rules from a previous section. Well, now I have sine squared, so I have to use the rules if this is squared. So remember, bring the 16 out, and then apply the power reducing formula. That's 1/2 times 1 minus cosine 2 theta, d theta. And you can bring this 1/2 in front and make that an 8 times the integral of 1 minus cosine 2 theta, d theta. And what is the integral of 1? That's going to be theta, because this is d theta. What's the integral of negative cosine 2 theta? That's going to be negative 1/2 sine 2 theta plus c. Now, this is different from any problem, either of these two that I've worked before. I haven't just got a theta by itself. And this is different. I have sine of 2 theta here. Okay, so I need to figure out how to write an algebra term for this, for the theta, and an algebra term for sine of 2 theta. I still need to make my triangle, like before. Make your right triangle. And what's the key to making this right triangle? Where you have x equals. So if x equals 4 times sine theta, then sine theta equals x over 4. And remember, in right triangle trigonometry, sine is opposite over hypotenuse. So if I make this theta, opposite side is x, hypotenuse is 4. This side down here is going to be the square root of 16 minus x squared. Alright, so how do I write theta? One way that you can write this angle measure theta is by using the inverse function. And I would suggest using the inverse sine function, because we use sine here to define this triangle. And so what you can say is the arc sine of x over 4, arc sine of x over 4 is equal to theta. So where you have a theta here, you plug in an arc sine of x over 4. This is 8 times arc sine x over 4 minus, alright, this right here, sine of 2 theta. When you have sine of 2 theta, or cosine, if we would have had just cosine of 2 theta, you need to use one of the double angle identities. There is a double angle identity that states that the sine of 2 theta is equal to 2 times the sine of theta times the cosine of theta. This is something that you would learn in trigonometry, in your trigonometry class. So I have a 1/2 in front of mine. So if I plug in 2 sine theta cosine theta, the 1/2 and the 2 cancel out. And so I just have sine of theta times cosine of theta. So I need to figure out what is sine of theta. Well, you know what sine of theta is. It's opposite over hypotenuse, x over 4. So that's sine of theta times what is cosine of theta. Cosine is adjacent over hypotenuse. So it's the square root of 16 minus x squared over 4. And so now you can distribute this 8. And when you do that, when you multiply the 8 in, that's going to be 16 down there. So you have an 8 with the first term, arc sine x over 4. Then 8 times this thing, 8 and the 16, that's going to leave you with 2 in the denominator. Your numerator is x times the square root of 16 minus x squared plus c. Now, when you just have a theta, this is one of the only times you'll have a trig, something trig, in your final answer. Okay. All right, let me do one of the different substitutions. I've been doing the sine substitution every time, but let me find a good example of one of the other substitutions. Let's say that I had the integral of x cubed over the square root of x squared minus 25. Now, if you do mistakenly use one of the other substitutions, when you plug it in and factor out to try to simplify the radical, it won't work. You won't be able to use a trig identity to simplify. So that's one way. If you start plugging things in and then what's under your radical doesn't simplify where you can plug in the Pythagorean identity, you know you've set it up wrong. You've used the wrong substitution. Okay? But so let's see, what substitution is that? We had a square root of x squared minus 25 in the denominator. So x squared minus 25, u squared minus a squared. So this is a u equals a secant theta substitution. So u equals a secant theta. How did I know that? I saw this in either the numerator or denominator. I had the square root of x squared minus 25. I had a square root. That's kind of what gave it away. And it's not a u substitution. You can't let that be your u and have your du. That doesn't work. So that's u squared minus a squared, variable squared minus constant squared, where u is equal to x and a is equal to 5. So x equals 5 secant theta. That's my substitution I want to use. And dx is equal to 5 secant theta tangent theta. Alright, so let's plug these in for x. Let's plug this in for dx, and let's plug that again in for x, down here where it's x squared. Alright, so I'm going to have, plug that in for x up here, that's going to be 5 to the third, or 125 secant cubed theta, over, and don't forget your dx, that's times 5 secant theta tangent theta, over the square root of, when you plug in 5 secant theta here, you're going to have 25 secant squared theta minus 25. So how will that factor? 25 times secant squared theta minus 1. This is a trig identity. It's a Pythagorean identity. That is equal to tangent squared theta. So you have the square root of 25 tangent squared. That's just 5 tangent. Alright, so this is the integral of, now what is that? I said I was going to have a 5 tangent in the denominator, so that is going to cancel that 5 out, but I'll just write it up here first. That's 625, and that's going to be secant to the 4th theta tangent theta over 5 tangent theta. Alright, so you can cancel out between here and here and give you 125. You can also cancel out the tangents. Remember, that's d theta as well when you plug it in. So that's going to be equal to 125 times the integral of secant to the 4th theta d theta. Now you need to follow the rules from a previous section where I told you how to integrate secant to an even power. Secant to an even power, you bring out a secant squared and then convert the remaining secants to tangents. So that's 125 times the integral of secant squared theta. Now I'm bringing a secant squared out, and that leaves a secant squared theta, and you have to change that into tangents. Alright, so secant squared theta is the same as tangent squared theta plus 1. Now this is another one of those plus 1s in here with just the du on the outside, just like that integral of sine earlier. You have to be careful because this secant squared that you pulled out is the du for the tangent, but it's not the du for 1. So if you want to think about it like it's secant squared, tangent squared times secant squared plus secant squared, you can think of it like that. That's probably the easiest way to think of it. Multiply that back in. Usually you don't multiply that back in, but since it's a plus 1, that's going to be a plus secant squared. So when you integrate those separately, the first integral, you let u equal tangent, so du equals secant squared. So it's present. This one right here, you can integrate secant squared. Remember? The integral of secant squared is tangent. Alright, so this is 125. If that's u squared, that's going to be u cubed over 3, so times u cubed over 3, plus the integral of secant squared is tangent. Alright, what was u? U was tangent, so that is 125 times tangent cubed theta over 3 plus tangent theta plus c. And I don't know why I put a du on that side, it's plus c. Alright, so now we need to make a right triangle, and here's the key to making the triangle, this right here. X equals 5 secant theta. If x equals 5 secant theta, then secant theta is equal to x over 5. Now what is secant in terms of right triangle trigonometry? Remember, that's the reciprocal of cosine. Cosine is adjacent over hypotenuse, so this is hypotenuse over adjacent. So the hypotenuse is x, the adjacent side, well, let's make it to this angle. The hypotenuse is x, the adjacent side is down here is 5. This side over here is the square root of, you guessed it, what I had in the original, x squared minus 25. If you don't believe me, again, make this some variable and solve for it using the Pythagorean theorem, and that's what you'll get. Alright, so we look back at our answer down here. We need tangent of this angle measure. Tangent is opposite over adjacent. So it's the square root of this, x squared minus 25 over 5. Now when you plug it in here, you're cubing it, so be careful there. You might want to go ahead and multiply this 25 times both of those. So if I did that, I'd have 125 over 3 times, now when I plug in here, I have to cube. Opposite over adjacent. So I'm cubing the square root of 25 minus, the square root of x squared minus 25 over 5. Plus 125 times the square root of x squared minus 25 over 5. Now I don't have to cube that one, right? That one's just to the first power. So when I cube this one, this bottom is going to become 125, isn't it? Because 5 times 5 times 5 is 125. So that's going to cancel that and just leave me with 1/3. What does the numerator become? That's to the 1/2 to the third, so that's to the 3/2. Power to a power, you multiply. This, that, and that cancel out, gives you 25. And that is x squared minus 25 to the 1/2. Now you can factor this one and simplify it a little bit if you want to. That's what the good student wants to do. They always want to try to simplify. So if we factored this out, then what would we be left with? And I'm going to factor out a, what else could I factor out? Maybe a 1/3. But doing that, that means I'm getting a little tricky. So if that confuses you, then just kind of do it one step at a time. But what you can do is you can factor out a 1/3 and an x squared minus 25 to the 1/2. If you do that, you're going to leave x squared minus 25 to the first. Now, how do you factor a 1/3 out of that, you may think? Well, whenever you factor this thing out, you just leave a 25 there. You factor this out, you just leave a 25. So I just need to say 3 times 25. So it's going to be plus 75. And so you can put those two constants together now. So that's 1/3 times the square root of x squared minus 25 times 50 plus x squared plus c. That is the most correct answer. All right. So regardless of what type of substitution it is, you do it the same way. You first figure out what type of substitution is it, what type of trig substitution. Then say u equals a sine theta, tangent theta, or secant theta. And it's going to be x equals, x equals, x equals. Unless this isn't just an x squared. Maybe that's a 4x squared. So then that would be 2x. So you would need to be careful for that. But once you figure out what type of substitution it is and you make the appropriate substitutions, you integrate, then you make the right triangle and you change it back to algebra. Okay? So there are a couple of special cases. If you don't have any other x values to plug into, meaning you only have like the radical, then your book does give you formulas for those. Usually I would derive those formulas, so I may have derived those in class for you. If not, I usually tell my students just to write these formulas down, because if you run into it, then you can just look at the formula and plug in the appropriate values. And here's the special integration formulas. If you just have the square root of a squared minus u squared, or just a squared square root of u squared minus a squared, or square root of u squared plus a squared, then figure out what a is equal to, figure out what u is equal to, and figure out what du is equal to. And then you just plug in the appropriate values into the formula. Okay? So that's just, if you have those, it's pretty much plug and chug. You do have to adjust for your du. For example, let's say that I wanted to do the integral of (25 minus 4x squared), the square root of 25 minus 4x squared. So my u is equal to 2x, so my du would be equal to 2. Now I don't do the trig substitution because I notice that this don't have any other x's out here. It's not a fraction where I need to use a trig substitution. I can just follow the formula. This is a special case. Alright, I just need to adjust for this du, so I'll need to first bring out a 1/2, and now I will follow the formula here. So this was 25 minus 4x squared, so minus, I had 25 first, so it's this formula. I had the constant minus the variable, and so it starts out with 1/2. Okay, so since it starts out with 1/2, and I have a 1/2, that's going to be times another 1/2. Alright. and this is, I want to follow this top one, so it's a squared and what was a? I didn't write that down, so a is going to be 5 because that's a squared. So this is going to be times 25 because it's a squared, arc sine u over a, so 2x over 5 plus u, which was 2x, times the square root a squared minus u squared, that's 25 minus 4x squared, plus c. So then all you'd have to do is multiply both of these numbers times 1/4. So that'll be 25 over 4 arc sine 2x over 5. So that's going to be plus x over 2 square roots of 25 minus 4x squared plus c. Alright, so just follow the formula and plug things in. If you have just the square root of a squared minus u squared, square root of u squared minus a squared, or square root of u squared plus a squared. How are the problems different that I've been working out? You have other things here other than just that square root of a squared minus u squared. You also have this up here. So we have to use a trig substitution when that happens. Okay? Now remember, when you have a theta, you need to use the function that you use to define the triangle with, and use the inverse of that function to define theta. So if this would have been sine equals this would be, if it would have been cosine, this would be arc cosine. So you always want to use the function, and you just use that definition there. This was tangent theta equals x over 4. This would be arc tangent x over 4. That's what I would plug in for theta. And then if you have a sine of 2 theta, use the double angle formula. Sine of 2 theta equals 2 sine theta cosine theta. Okay. You definitely got to practice these to get better at them. So make sure you work through the ones on your homework, and if you have any questions, I can help you with those.